Policy objects. Versa Networks policy uses objects that are stored in the local database to define network traffic properties. There are four main groups of object types that can be used for traffic management: address objects, application objects, URL objects, and IP objects. Address objects are based on the IP address or address range. Stateless and basic stateful firewall rules allow or deny sessions based only on the IP address field of a packet and Layer 3 and Layer 4 properties. With address objects, the IP address can be associated with a name or group of addresses. When multiple rules refer to an address object, if the address object is changed by the administrator, all rules that refer to the address object inherit that change. Application objects allow applications to be defined and associated with a purpose or reputation. Once the application identification process identifies the application name can then be compared to additional information to determine whether the application should be allowed based on more than just an application name. URL objects allow the association of a URL to additional properties, such as a URL reputation or URL category. An action can then be taken on a session based on the type or category of the URL, and not just on the URL string. IP objects allow the association of an IP address or set of addresses to additional properties, such as geolocation and IP reputation. The IP address object concept is widely used in the network security world. Instead of matching on a prefix in a policy, the policy can match on an address name that is associated with an IP prefix or address. This system creates a central database of address objects that can be used by multiple policies, rules, or processes. This allows policies or processes to reference a central definition of an address or address group, which can be very important when dealing with complex security or service processing. When addresses are stored as objects in a database, multiple processes can access the address object for reference in policy functions. If the properties of an address or address group change, the change can be made in the central address database by changing the object. Because multiple policies or processes may reference the object, all of the policies or processes that reference the object are updated with a single address object change, and the policies themselves don't have to be changed or updated. By creating addresses in a database, the addresses become available to any policy or rule that is created on the device. If the address is referenced in 1, 10, or 100 rules, a simple change of the address definition in the database updates all of the rules that reference it. The addition or removal of an address from an address group allows the administrator to modify traffic matching parameters without having to go through all of the possible rules that may require an update. For example, if the LAN address at Site 10 changes, and there are many policies and rules that scan for traffic from Site 10, a simple update to the IP address in the Site 10 address object effectively updates any policy or rule that looks for Site 10 traffic. Address objects are stored in the Objects and Connectors hierarchy of the Versa operating system. Both addresses and address groups are located in the Objects hierarchy. The image shows a simple example of multiple address objects that can be referred to in policy, as well as two example address groups that group the addresses together. Both the individual address objects and the address group objects can be used in policy to match IP addresses. Application objects store application information in a central database. The application object contains the application name and a set of properties associated with the application. The extra information associated with the application is called metadata. Metadata is simply a set of data that describes and gives information about other data. For example, an application has a name, protocol, and port information. However, the name, protocol, and port information does not indicate the trustworthiness, productivity, or other properties of the application. To filter or sort applications based on information other than the name, protocol, and port, additional information must be provided about the application and stored for reference. Application metadata, or data that describes the application, is provided in the security package that is loaded onto the device as part of the next-generation firewall functions. Application filtering in security policy can be based on the application name alone, or the application name can be used to direct the session to an application filter that analyzes the application information in more detail. The application filter can allow or deny application traffic based on the tags and other metadata associated with the application. With the more detailed application filtering, the access rule is used to identify the traffic, but the access rule does not determine whether to permit or deny the traffic. Instead, it redirects the session to the application filter engine. Application objects provide a lot of extra information about an application beyond the name, protocol, and port. Application family and subfamilies can be associated with the application, as can risk and productivity ratings and additional application tags. When an application filter is created, a session can be permitted or blocked based on any of these properties or combinations of properties, and not just on the IP address and application name. URL objects store URL information in a central database. Similar to the application objects, URL objects provide additional information related to a URL that goes beyond the URL string. There are three main types of information that can be associated with a URL string: a URL category, a URL reputation, and a URL profile. When a URL is analyzed by the policy engine, the session is analyzed and can be sent to a URL filter based on the URL category or the protocol type, such as HTTP or HTTPS. Once the session has been passed to the URL filter, the properties associated with the URL string can be used to determine what action should be taken. This provides much more flexibility and control over web filtering than just a URL string-based decision. URLs can be allowed or denied based on the URL reputation, category, or based on behaviors associated with groups of URLs in a URL profile. The URL filtering process is a multi-step process in the Versa operating system. First, a security policy rule analyzes the session and identifies the session properties. Because URL filtering is exclusive to web traffic, it's common for the rules to identify HTTP and HTTPS traffic as matching criteria. The rule can choose to allow or deny the session based on that basic information, or it can choose to send the session to the URL filter process for further analysis. If the rule sends the session to the URL filtering process, the URL filter gathers more information about the URL from the local URL object database. The decision to allow or deny the session can then be based on the metadata associated with the URL, such as the URL reputation or category. If the URL reputation changes in the database, the change will be reflected in the next security package update, and the URL may be treated differently based on the new reputation information. However, no change is required in the policy to make an adjustment to the URL treatment. URL reputations are stored in the Objects and Connectors hierarchy. URL reputations are predefined objects. A URL is then associated with one of the predefined reputation levels. URL categories are industry-defined categories, and a copy of the categories is stored in the Objects and Connectors hierarchy. URLs can then be associated with the predefined categories. URL profiles are used to group URLs together into a profile, or a group behavior for a set of URLs. There are several predefined URL profiles pre-configured in the Versa operating system. IP objects are similar to URL and application objects. Filtering traffic based purely on IP addresses can be overwhelming and unreliable. IP addresses and the end hosts associated with them can change frequently, and people with bad intentions deliberately change their IP addresses as they attempt to compromise networks. There are groups of IP addresses that are known to be from malicious sources, or that are known command and control IP addresses for bots and malware. IP objects associate metadata, or extra information, with IP addresses, so that filters and policies can be configured that rely on IP reputation, geolocation, or IP profile information. Actions can then be determined based on the information associated with the IP address instead of being based on the IP address itself. If addresses are added to or removed from known malware systems, the policies that allow or block traffic based on malware-associated addresses are automatically adjusted when the security package is updated on the device. IP filtering is a two-step process. A security access rule identifies the traffic. Based on the rule match conditions, the security access rule can allow or deny the session directly, or it can direct the session to the IP filter for further analysis. If the access rule passes the session on to the IP filter process, then the IP filter process analyzes the traffic in more depth and determines what action to take. IP filter profiles bundle IP address categories into groups and assign default actions for the groups of IP addresses and define a match type. IP reputation groups are combined within the profile along with their associated action. IP reputations are predefined in the system and are associated with groups of IP addresses. Because the IP addresses associated with reputations change from time to time, and the number of IP addresses is so extensive, the addresses associated with each reputation are not displayed. The ability to include or exclude IP addresses from reputation-based actions is discussed in the configuration examples.